Hello, so in this video, I'm going to go through how I made the blueprint for spawning different Niagara particle system uh, when we shoot different meshes. So for that, we need a different physical material for different types of surface. So for that, if we go to edit project settings, if we search for yeah, if we go to physical, if we search physical, so it's in physics, it's physical surface, and we have bunch of like 62 different surface that we can assign. So here I assign different surface like metal, concrete, wood, plaster, and so on. So once we assign write different surface names, uh, what we need to do is we need to make a folder, and in this folder we need to just go to right click, and we'll just search physmat or physical material, and we'll just create physical material, and we'll name pm test. So this will be the another test material. If we go here, and we have different parameters for like friction, static friction, restitution, density, and velocity threshold. And here it has surface type, so we will select which surface this will be assigned to from the one that we made. And then once we have this, we can use this physical material on different meshes. So let's say here in this mesh, if I search on physmat, it has phys material override, and here I can assign physical material metal. We can also assign it into actual material as well. So if I have mi material, we can assign phys material here as well. It depends on like different materials, so we can assign uh, different physical material for each of them. Here, and now if I go to the first person and input, so I have made different input actions. So I went to actions folder, and just right click, and if we make search, so we have this option for input action, and if we create this, we have this option where we can create a different input action name. So it will just the name of the action. It won't do anything. It's just like the name of the action and how it will be triggered. So if it's like pressed or hold or released, or we can set how we want to trigger this input action event. And once I create the shoot bullet, shoot flame, and shoot grenade, and shoot and slow motion, uh, then I went back, and I made this input mapping context where I click on plus, and we can add any of our input actions like this. So we have these three, and here we can assign which key they will be associated with. So for the shooting grenade, it's middle mouse and gamepad left trigger, and for shooting bullet, it will be left mouse and gamepad right trigger, and for shooting flame, it's right mouse button. So yeah, I made the input mapping context, and then once we have this, we go to the BP weapon component, and here if we want to um, trigger input any event using input action, we can just search through like input action, and we have all this like shoot bullet, shoot flame, shoot grenade, and then we can, once it triggered, we can uh, assign different blueprint nodes, and it will uh, run this code. So for the bullet, shooting bullet, um, so once uh, if we click, if we press left click, it will trigger this flow, and once it triggered this flow, it will play the montage of the animation, which is the default. This is the default Unreal thing. I didn't do anything with this one, so I just assigned this thing where it will play the shooting animation, and then this is the bullet fire logic. So where so we when we shoot the bullet, we want a muzzle flash on the tip of our uh, gun. So to do that, what I did is I used the node spawn system attached, and here in the system template, we select any Niagara particle system that we want. So I attach NS muzzle flash, and attach component would be self, and here attach point name, it would be muzzle. So the muzzle is the socket name of the gun. So if I click this skeleton mesh, yeah, we have two socket. One is the grip point, which is here, and another is the muzzle, which is here. So it will use this. It will use this muzzle socket to spawn the Niagara particle system for the muzzle flash. And for the location, I use the get socket transform, and for the socket name, I use the muzzle, and in the return value of the location, I use the I connected it with the location, but I get the forward vector and uh, multiplied it with 15, so it's basically like slightly ahead of the nozzle of the gun, like 15 units multiplied by the forward vector, and it will be added in this one. And then for the rotation, I just connected the return value. So once we have the um, muzzle flash, and then I connected this play sound at location, and here we just connect where we want the sound to be and which sound we want to be played. So it's just a firing sound, and then it's the line traced by channel, where it will trace which surface it hits on. So for the line traced by channel, we need to actually cast this blueprint to the first person, because this is the BP weapon component blueprint, and we want this to be cast from the first person character. So I use the cast to BP first person character, and for the object reference, we use get player character. And then from here, we use the line trace by channel. And in the start, uh, we will get the first person camera and we'll get the world location. So the world location from the world location of the first person camera would be the starting point, and it will fire a beam, not the beam, but the a line of like a line trace, and it will trace the line from the position of the camera to towards whatever the end location we put. So the end location would be the same one, but with we'll get the world rotation and get the forward vector. So we get the front facing vector from that direction, and this is the uh, range of the vector. And if and I've set it to 3000, so it will go till 3000 unit, and whatever the obstacle will come in between, it will end at that point. And then I added with that world location. So once we add this location with this, we'll get the end. So if I click on um, debug type to for duration, if I compile and go here, and if I click, you see we have this line that goes from the player camera to whatever object it hits on, and the range is 3000 units. So if I click here, it will stop at here, which is 3000 unit away from there. So it doesn't shoot towards all the way towards the that wall. It will have a certain range, like it will shoot over there, but it won't go all the way over there. So mm, yeah, so once we have line trace by channel, what we want is we want uh, uh, the break hit result. So that's how we will get which mesh it has been collide with. So with break hit result, we will use the branch node. So if it meets a certain condition, it will do this thing, and if it doesn't, then it will do another thing. So it has true and false. So now the condition is if the thing whatever we're shooting has is simulating physics or not. If it's simulating physics, then it will spawn another blueprint, which is bullet filled, which will cause the damage to the mesh. So it will just create the chaos um, uh, chaos impact on that location, and then it will break the mesh if if that mesh is simulating physics. It's if that mesh is not simulating physics, it will go through here and it will just do the other thing, which will spawn specific Niagara particle system on the impact. So here, if it's true, which is the hit component, from the hit component, I use this node is simulating physics. And if it's yes, then it will spawn the BP underscore bullet filled blueprint. and then it will go here. And if it doesn't, it will go directly to the spawning of the Niagara. So here I use this switch on ePhysics surface, which we have a different physical material that we assigned in the in the physics tab in the project settings. And here the default one. So if it has the default physical material, it will go through here, and then it will spawn this concrete uh, location, spawn concrete Niagara particles system. So I use the node spawn system at location, and I selected NS bullet impact concrete. And for the location where we want it to be, the location is the brick hit result from the line trace, and we'll set the location to over there. And for the rotation, uh, we want the normal, and once we get the normal, we use the rotation from x vector, and then we connect it to the rotation. We can also connect the we should use this node for uh, the delta rotator, just in case if our Niagara particle system isn't facing the forward x direction. So let's say if I accidentally made a Niagara particle system which is facing the z-axis or y-axis, we can rotate it from here, and it will face the correct direction. So, but all of my Niagara particle are facing the x direction. So uh, if we don't use this node, it will be okay. But just in case, if we use different particle system, we can just change the rotation value from here. So it is using the same logic for all of this. So if it's default, it will use the concrete Niagara particle system, and it will spawn as this impact location, and this will be the rotation. We'll check on auto destroy. So after spawning the Niagara particle, once it's finished, it will despawn and it won't store in the memory. And if it's metal, it will go here, and it will use the metal, concrete, and wood, plaster, glass, and so on. And once we have all of this, what it will do is it will play a sound at a location, because once we hit a metal, we want metallic sound. So I use this node play sound at location, and for the location we use the same location as this, where it hits the where it hits the hits by the line trace channel. And I use three different array for different sounds. So I have this array called metal hit, and in this one I imported three different metal impact sound, and I use random node, so it will choose randomly between these three and play the sound, so we have more variations. Did the same with the concrete and wood and plaster, and I had only one sound for the glass, because I downloaded all these sounds from a free website, which I will link in my blog. And yeah, so then I connected all these nodes for the different material surface sound, and then this is for the debug purpose I did, just to print string that which actor we are hitting, get the display name of that object. So, and then once it hit the mesh, we want a decal to be spawned. So I use this node spawn decal at the location, and then the we can choose which decal we want, and we can change the decal size. We can set the location the same way that we did for the particle system, and for the rotation we will do the same thing, but our we will do this one random integer in range, and we will add the rotation value, so it will rotate the decal randomly, so it looks like it's different decal. And then we'll use set fade out, and the lifespan of this decal would be 5 seconds, and then it will start fade out from the 3 second to fifth second, so it's 2 second duration. And I will check destroy owner after fade, so then it will fade out in from 4 and 5 second. So yeah, this was the bullet file logic. And this, and for the grenade launcher, I use this um, shoot grenade input action, and once it's triggered, it will it will spawn bp underscore grenade launcher projectile, and then it will play the sound at the location, and it will spawn a system attached, which is this Niagara smoke launcher at the for the muzzle flash thing, and then it will play the animation, and that's all. This for the flamethrower logic, but this is for my stretch goal. I didn't finish this part, but yeah. So this was the um, blueprint for the shooting. So if I compile and if we play it based on the different mesh, we have different particle system spawning.